where we're going to take the previous system that we solved, and I'm going to show you how we get this done with the calculator. So what we can do is we can store the system into a matrix in our calculator, and that's where the brackets come in. Use that for matrices. And remember, we called that a reduced row echelon form, our final answer, and they have the program built in. So we just have to run this program with that matrix, and look, it gives you the answer. So this is like you're working in your textbook, and remember you used to put the paper clip or a folded up piece of paper in the back of the book, and you peek at the answer and say, okay, that's the answer, I got to figure out how to get to it. That's exactly what we're going to do here. I want you to do the calculator first so you know what the answer looks like, and then work it out by hand, because I don't want you to make a mistake and then have to redo the whole problem by hand over again. So we can probably get maybe through 2/3, and then you can see the calculator is going to check your work to see if you need to continue or go find your error. All right, so let's go ahead and walk through this with the calculator. So I'm going to slide my calculator over. I know I'm covering up the directions, so you can always just pause it and read through them whenever you need to. All right, so here we go. Let's see, I think I'll even clear the bottom of my calculator here, so in case you miss a button pushing, it'll be down there at the bottom of the screen. How does that sound? So, okay, I thought I could move this up. There we go. Okay. So let me get my system visible here. There it is right there. Okay, so we're going to go second matrix, x to the -1 button right there. So we have 3 drop-down menus: names, math, and edit. Names, this is where you store your matrices. Math, this is where all the programs that you can run on your matrices. Edit, this is where you enter all your matrices, and then it stores them under names. So we'll do matrix A, so I'm going to go ahead and hit enter. And now they're asking for what they might say the order or the dimensions of the matrix. It's always rows by columns. So we have 3 equations, that gives us 3 rows, and we want 4 columns, 1 for the x, 1 for the y, 1 for the z, 1 for the result. So 3, enter, 4, enter, and it gives us an empty matrix full of zeros, and now we put in the numbers. And you enter these by row. So when you hit enter, it's going to slide over to the right. So 3, enter, 9, enter, 6, enter, 3, enter. Notice it dropped down to row 2. Okay, let's put in the second equation. 2, enter, 1, enter. Now -1 goes in as -1, not -1. You'll get a syntax error. Enter, and then the 2. Now for the third equation, we have 3 1s, and then a 2. And every time you hit enter, it's automatically saved, so you don't have to worry about saving it. So we'll go second, quit, get out of the edit mode, back to the home screen, so we can paste in that RREF command. So we're going to go second matrix to the math drop-down column. I scroll up. I don't want to scroll all the way down because it's right at the bottom of the list, right about here. So if I scroll up, I'm looking for B, RREF. That's what I want to choose. Then you hit enter. It pastes it into the home screen. Now we got to put matrix A into this program. Second matrix. There it is, already highlighted, so just hit enter. Close up the parentheses and hit enter. And there's the answer we got in the last video. Okay, so now how do I want you to do your work? Okay, so here we go. So bear with me here. Don't peek at the answer. Just listen. Okay, here we go. There's my system. I'm going to kind of cover that up right there. And then we'll run the show, and I'll show you what we're going to do with our calculator. Okay, so enter this matrix. second matrix to the edit screen, enter, and you can just skip over that, so you can just hit down arrow or enter twice. And let's see, we need 2, 1, 4, 7. 2, 1, 4, 7. Then we need 3, 4, 1, 13. And then we already have the 1, 1, 1, 1. We just got to change the 2, or excuse me, the 2 to a 4. Enter. Now, another thing that you should get good practice doing is, because you entered them in rows, double check by columns. 2, 3, 1. Good. 1, 4, 1, 1, 4, 1. 4, 1, 1, 4, 1, 1. 7, 13, whoops. 7, 13, 4, 7, 13, 4. Because if I accidentally typed in, say, this 4 right here wrong, everything below it and everything to the right in both columns is going to be wrong answers. Okay, so really make sure you got these right. Now, the nice thing here is when we go to the home screen, second quit, you can just go grab that previous entry. Paste it in, hit enter, and there's my answer. All right, so wait a minute. I don't have a downhill diagonal of 1s. What's going on here? Oh, yeah, look at this last row here. 0x plus 0y plus 0z is equal to 0. That's a true statement. When you get the z at the end here to cancel out, you're going to have infinite solutions. All right, so now when we go work this out by hand, this is what we're looking for an answer. All right, so if you got this on your calculator, just put your calculator to the side, and now we're going to go work this out by hand. Well, I want to move my calculator onto my other monitor here in case I want to bring it back in. Okay, so here we go. Because you want a 1 in the upper left-hand corner, and my third equation starts with a 1, I'm going to do a little row switcheroo. This is the symbol for switching rows. So equation 1, equation 3, I'm just going to switch them. Equation 1 down to row 3, equation 3 up to row 1. And I like to do that before I build the matrix, because I hate to copy the matrix over just to switch 2 rows. All right, so next, 1's been established. Make these into zeros. You have to add the opposites to these. So the opposite of positive 3 is negative 3. Negative 3 gets multiplied to the 1 in row 1, added back to the 3 in row 2, and that's your new row 2. So there's my row rule. So negative 3 times 1, 1, 1, and 4 are going to be all moved to the second row. Negative 3, negative 3, negative 3, negative 12. Then the 2 has to become a 0, so the opposite of 2 is negative 2, so we're going to go negative 2 times row 1. That's where this 1 is. Add it back to the row 3, where the 2 is, and make a new row 3. So negative 2 times those 3 1s will all be negative 2's, and negative 2 times 4 will be negative 8. Add up the numbers, crunch them out. We get 0, 1, negative 2, 1, 0, negative 1, 2, negative 1. We have a 1 here. Now, bear with me, you do not have to copy this again. I'm just changing them all back to a black font because I want the rows that I'm changing to be in a different color. You don't have to do this change. I'm just doing it so you can see what changes are being made. So working with this matrix, or you could be working with this one, it doesn't matter. 1's established, we need to make these 2 into zeros. So opposite of 1 is negative 1. Times the 1 in row 2 and add it back to the row 1 to make that our new row 1 where there's a 0 there. So negative 1 times 0, that's 0. So we're always adding a 0, no change. Negative 1 times 1 is negative 1. Negative 1 times negative 2 is positive 2. Negative 1 times 1 is negative 1. And if you notice, row 2 and row 3 are completely opposites of each other, so we just want to add those 2 rows together, row 2 plus row 3, and make that the new row 3. So basically we're just moving row 2 down next to everything in row 3, Add these all up, and there's the bottom row of zeros. Do the number crunching on the top, 1033. And again, if you look at your calculator, even at this point, this was a good sign. That second row already matched what you had in your calculator, so we know we're doing things right. Then when we get to this next step and we're done, there's your bottom row of zeros. Your top row is the same. There's my answer. So all zeros at the bottom, like I said, infinite solutions. Z is the independent variable. So you take row 1 and row 2 and you build a mini system. 1x plus 3z equal to 3. 1y minus 2z equals to 1. And you solve these for x and y. And they'll be solved in terms of z in the answer. So I'm going to subtract over the 3z. I'm going to add over the 2z. Perfect. Remember I said z is your independent. Y is now 1 plus 2z. X is now 3 minus 3z. And there is my infinite solution. All done. All right. Okay, next problem. Okay, so let's do this again. Get your calculator, enter those numbers, enter the numbers. All right, so I'm going to go over to my calculator, probably mess up my screen again, but that's okay, no big deal. We can always adjust it. Second matrix, go edit, enter, change your numbers, edit, edit. 5, 3, 9, 19. 5, enter, 3, enter, 9, enter, 19, enter. 3, 4, oh, we already got 3, 4, 1, 13. Oh, it's the same middle. Oh, how convenient. All right, down arrow. 3, enter, 2, enter, 5, enter, 12. All right, double check your numbers. 5, 3, 3, 3, 4, 2, 9, 1, 5, 19, 13, 12. Second quit. Copy that RREF. So copy it, enter, and oh, what do we have here? 0, 0, 0, 1. That means we now have 0 equal to 1. That's a false statement, which means that's no solution. So all I have to do to prove a no solution when I do this by hand is to get 3 zeros and something right here that's not a 0. It doesn't mean it has to be 1. Anything but a 0 and you're done. Okay? So on no solutions, I'm not going to make it look like what my calculator said. Okay, I knew it. It went blue. There we go. Okay, so we put in my numbers. 5, 3, 9, 19, 3, 4, 1, 13, 3, 2, 5, 12. Oh, rats. How to make a 1, how to make a 1. Okay, this is where I'm going to cheat. I'm going to take 2, multiply it to the 3 in row 3, which makes that a 6, and then subtract the 5. So 2 times 3 is 6, minus the 5. 2 times 4 is 8, minus the 3. 2 times 1 is 2, minus the 9. 2 times 13 is 26, minus the 19. Crunch the numbers. 1, 5, negative 7, 7. That's better than having 1 and taking all of row 1 and dividing it by 5. To have a 1, 3/5, 9/5, 19/5. That's something I don't want to work with. Now that the 1 is established and we have all integers here, let's make these zeros. And oh, this is convenient. They're both negative 3, or both 3's. So negative 3 times the 1 in row 1, added back to the 3 in row 2 is my new row 2. And since this is a 3 as well, we're going to have the same numbers. So negative 3 times 1 is minus 3. Then we're going to have minus 15. Negative 3 times negative 7, now that's plus 21. Then negative 3 times 7 is minus 21. And you have the exact same numbers in row 3 because we got a 3 down in row 3 to start off to make a 0. So we'll crunch the numbers. 1, 5, negative 7, 7 doesn't change. we get 0, negative 11, 22, negative 8. We get 0, negative 13, 26, negative 9. Now remember, I mean, these are ugly numbers here. I'm not going to argue. Remember, all we had to do was get 3 zeros and something that's not a 0. I'm not even going to bother with row 1 anymore. So looking at row 2, I need to make this into a 1. So I'm going to divide everything here by a negative 1. Excuse me, negative 1. Negative 11 to make it a 1. Well, while I'm here, since that's going to become a positive 1, and I notice like 13 and 26, 26 is divisible by 13. Let's take row 3 and divide it by a positive 13. Now here's my thought process. This will become a positive 1. This will be a negative 1. I can add those right away, and they're opposites. So I crunch the numbers. Row 1, again, I'm not touching it. I get 0, 1, negative 2, and a positive 8 elevenths. 0, negative 1, 2, negative 9 thirteenths. Don't worry about these numbers over here. Notice that, oh, how convenient. Oh, I knew this had to happen. If I add row 2 and row 3, I know this is going to cancel out to zeros. And if I add these two together, I'm going to get something that's not 0. These are not opposites of each other. So they're not going to be a 0. So I'm just going to do row 2 plus row 3. I get 0, 0, 0, and I'll be honest with you, I went to my calculator and did 8 divided by 11 minus 9 divided by 13. Asked my answer to be a fraction. There it is. It's not a 0. That's all I need to show right there. That's no solution, and I'm done. Okay? And that wraps up part 2.